Greetings, students. Today we're going to be discussing practice test 3-6. Let's begin. Question 1. So here we have the shape with 3x minus 6 and 8. So I'll put those in the numerator of my fractions. And the other shape has a 3 and a 4. So the 2x minus 6 becomes a 3. And the 8 becomes a 4. So that's a 2x minus 6. I can do diagonal multiplication here. I can divide 8 by 4 and reduce that. Or I can do a ratio here. And any of those will work perfectly fine. I'll do diagonal multiplication not because it's most efficient, just because that's what I feel like doing today. So 4 times 2 is 8x, and 4 times 6 is 24. So 8x minus 24 is equal to 24, therefore 8x is equal to 48, and x is 6. Again, I could have divided this, made it into a 2, tripled it to make it a 6, added 6 and divided that in half to get 6 as well. Question 2. The 25 relates to the 30 here, not to the 24. Because I don't have the bottom of these shapes. So it's 25 over 30, or 25 to 30. That divides by 5 to become 5 and 6. Next one. The smaller triangle has an x plus a 5 and a 13. Notice that the other triangle is isosceles. That means this triangle is also isosceles. So I don't actually have to do to the denominators on this particular question because it's isosceles. But if these lengths are different, remember that AE here goes with AB, so this goes with this. And then AF goes with AC, because that's what the statement tells us. That goes with that. But again, it is isosceles, so I can actually ignore the denominator here and set x plus 5 equal to 13 to get x equals 8. Next question, geometric mean. On previous tests, you've been able to do this with a pattern type of example or a pattern approach. Again, this is a multiplicative mean. It is the square root of the product. So it is the square root of 8 times 20 here. Square root of 160, which can be reduced because 16 goes into that 10 times into 4 root 10. The reason this is not an integer value is because when you double 8 it becomes 16, and when you double 16 it becomes 32. So if this had been 8 and 32, my answer would have been 16, because 16 is midway between 8 and 32 multiplicatively. But this is not an integer value because there's no integer number. There is no integer that is midway between 8 and 20 multiplicatively. Next two. Identify the triangle as acute, right, or obtuse based on the measurements, not the diagram. So these two diagrams, they both appear to be right triangles. They both look like they're right triangles, but they may or may not be right triangles. I'm asking you to do the Pythagorean theorem and verify if they are right triangles or not. So in other words, I'm asking you to take the sum of the legs squared, 6 squared plus 8 squared, the legs are 6 and 8, and evaluate whether it's equal, less, or greater than the hypotenuse squared. And we're going to call it the hypotenuse. I don't know if it's a hypotenuse. I don't know if it's a right triangle. We're going to call it the hypotenuse. So is 36 and 64, how does this compare to 121? Well, this is less than 121. In other words, the sum of the square of the legs is smaller than the hypotenuse squared, meaning this triangle is obtuse, because its legs are greater in value than the hypotenuse. Its hypotenuse is greater in value than its legs. When the square of the hypotenuse, it's greater in value than the legs. And it's not actually called the hypotenuse when it's not a right triangle. But c squared here is bigger than a squared plus b squared. The other one here, doing the same thing. I'm evaluating whether 10 squared plus 12 squared, how that compares with 15 squared. So does 100 plus 144 How does that compare with 225? Well, that is greater in value than 225. The legs squared this time are greater in value than the hypotenuse. And again, we don't call it the hypotenuse when it's not a right triangle, but then the c squared. So this one happens to be an acute triangle. All right, question 7. It is always worth your time to label the other portion on the triangle with the two given portions. So this is 36, this is 64, because it makes 100 total. And then you're going to look at what's labeled on the triangle here and determine your ratios. So x is on the same triangle with 36. It's on this small triangle with the 36. I'm going to put x with 36 here. X and 36 as my numerators. X is also on this triangle with the 64. On the medium-sized triangle. It is not on the triangle with the 100. Not on the big triangle, the large triangle. So it's on the small one on the left, x with 36. The mid-sized one on the right, x with 64. But not on the entire triangle with the 100. Anyway, so the proper placement for x and 64 here is the 64 underneath the x and the x underneath the 36. And the reason for that is because x is the longer side on the small triangle, but it's the shorter side on the mid-sized triangle here. So I'm going to get x squared is equal to 36 times 64. Now I can square root after I've multiplied this out, or I can square root before I've multiplied. So I can either do 6 times 8, because you square root 36 to become 6, and you square root 64 to become 8, or I can multiply this out and then square root that number. I'm going to choose to do 6 times 8 here, as it's going to be easier to accomplish without the calculator. Next one, Pythagorean theorem. We are looking for a leg, so we are going to subtract here. So it's going to be x squared plus 7 squared equals 12 squared, but we are subtracting because we're solving for x. So I'm going to subtract the 12 squared and the 7 squared here. So x squared plus 49 equals 144. Therefore, x squared is equal to, well, 49 from 144 is 95. 95 is 5 times 19. So that does not reduce. X is the square root of 95 here in this case. Does not reduce. All right, question 9 and 10 are the same question. Sorry about the bell. I've been doing this between classes. These are the same questions, they're just worded opposite. So how does the ratio of the lengths of corresponding sides of similar polygons correspond to the area, and how does the ratio of the areas of similar polygons correspond to the lengths, relate to the corresponding lengths? So in other words, if the lengths, we'll just do a couple of samples here. If the lengths is a ratio of 3 to 2, the area is the square of that, 9 to 4. The area ratio is the square of the length ratio. And the backwards of that statement is true as well. So if the area ratio was 49 to 16, the length ratio would be the square root of that, 7 to 4. The area of this is the square of the length ratio, and the length ratio is the square root of the area ratio in terms of words. This will be a numerical question on a test, not a word question, fill in the blank type question. Moving along, unit triangles, question 11 and 12. So here we have our special right triangles, our unit triangles, 30, 60, 90, and 45, 45, 90. So the ratio between the sides on the 30, 60, 90 triangle. Question 11. So on the 30, 60, 90 triangle, the ratio is x, x, and x root 3. Give me x, 2x, and x root 3. So across from the 60 is the x root 3 side. Across from the 30 is the base side x, and across from the 90 is the 2x side. So in other words, to get from this side, the one that's across from the 60, to this base side, I divide by the square root of 3. So 2 root 3 divided by the square root of 3 is just simply 2. And to get from this base side to the hypotenuse, I will double it. 2 times 2, 4. This is again called a special right triangle. The hypotenuse is double in length from the shortest side. And then this middle side, the longer side, not the hypotenuse, but the longer side, is times by the square root of 3 in terms of its ratio with the short side. Next one, 45, 45, 90. This is the isosceles right triangle. So this is isosceles, meaning these two lengths are the same because these two angles are both 45s. So B will equal 4, and then I can use the Pythagorean theorem to solve for A, or I can use the ratio x, and x root 2. So in other words, 16 plus 16 is 32, and the square root of 32 is 4 root 2. If I wanted to talk about that in terms of Pythagorean theorem, or I can talk about it as x, and x root 2. Alright, next one, trig ratios. Sine is opposite to hypotenuse, the relationship between the opposite side and the hypotenuse. So which side is the hypotenuse here? 17, the longest side. So this will be out of 17. And in relation to angle C, which side is opposite from angle C? The 8 or the 15? Well, opposite means across or not connecting to it. So 8 does not connect to angle C being this vertex here is angle C. So this will be 8 to 17, this ratio. 14 is a similar question, except it's tangent, so we're using SOHCAHTOA. So this is opposite and adjacent. So I'm not using the hypotenuse here. I'm still going to circle it. That's the hypotenuse. The longest side is always the hypotenuse. I'm just going to cross it out. I'm not using 37. I want to use opposite adjacent on this question. So again, the opposite side is not connecting to the angle. So here's angle A. The opposite side from angle A is 12, not connecting to angle A. So this is 12 out of 35. All right, next one, question 15. Here we're looking at, again, sine, cosine, and tangent. Just looking at a different aspect of it. So the sine of 55, cosine of 55, and the tangent of 55. One of these ratios is the proper ratio. The other two are not useful here. So I'm looking at this question. The items that are labeled. Here's the 55. I have the hypotenuse, so I'll circle this because I always circle hypotenuse. So I'm going to use either sine or cosine because I have the hypotenuse labeled. I'm not going to use tangent because the hypotenuse is labeled on this picture. So I'm not going to use tangent because the hypotenuse is labeled. And the question is whether x is adjacent or hypotenuse, whether the adjacent or opposite side from the 55. Well, x is connecting to the 55, so that is adjacent. So I'm using the cosine ratio, not the sine ratio or the tangent ratio, because I have the adjacent and the hypotenuse labeled. And the value of x here, again, you would, to finish this out, you can use the value of x, you would multiply 10 by the cosine of 55. That part's not as particularly important as setting up the ratio. As I've said in the past, I will most likely give you points if you have it set up properly, cosine 55 equals x over 10, because that's the part that you actually need to know how to do. 10 cosine 55 can be typed in the calculator to get approximately 5.7, 5 7/10. The calculator, however, cannot set up the ratio, which is what I need you to be able to do. Set up the ratio. Similar deal here. So on this one, again, we're looking at the sine of 41, the cosine of 41, and the tangent of 41. And one of these ratios is the one I want to use. The other two are not the one I want to use. So I'm looking at this hypotenuse. So I'm either going to use sine or cosine here again, because the hypotenuse is labeled. I'm not going to use tangent. The hypotenuse isn't labeled here. And the question is, again, whether or not that 19 is adjacent or hypotenuse to the 41. Well, it's across from the 41, not connecting. So in this case, I'm using the sine ratio. Because x is in the denominator, I would actually divide this to solve for x. So x would actually be 19 divided by the sine of 41. Because x is in the denominator there. Whereas x was in the numerator here, I times by 10. 10 cosine 55. Here it's in the denominator. 19 divided by sine 41. So x is approximately in value 28 and 96 hundredths, but I said round to the tenth, so approximately 29.0. Alright, next group. We're looking at area of a polygon. Start off with the perimeter. So you take the side length times the number of sides. 10 times 6 in this case because it's a hexagon. 60. And this one here, the triangle, 8 times 3. Because it's a triangle, so I do 8 times 3, 24. And then to get the area, you do half the apothem times the perimeter. Half of 8.7 times 60. So 1/2 times 8.7 times by 60. It's approximately 261. That's exactly 261. And then this one here, number 18, half of the apothem, 2.3 times 24. Half the apothem times the perimeter. So that's approximately 27 and 6/10. Half the apothem times the perimeter. Perimeter being the side length times number of sides. Hexagon's got 6 sides, triangle's got 3 sides. Multiply accordingly. Alright. Circumference and area. You noticed I said circumference here because arc length is the same as circumference. It's just out of the portion of the circumference that you're looking at. So 2 pi r is equal to the circumference. 2 pi times the radius. So this is 2 pi times by 12. This is 24 pi. But it's not the entire circle because I'm only looking at 120 degrees of the circle. So I modify this by taking the angle out of 360 to get the portion of the circumference that I'm looking for. So 120 degrees out of a full circle, 360. So I'm not looking for the entire circle, I'm looking for 1/3 of the circle. That fraction there, 120 over 360, makes 1/3 when it reduces. So 1/3 of 24 pi is 8 pi. 8 pi inches, or approximately 24 inches. I didn't say to multiply it in the calculator, so you don't have to. Alright, area is pi r squared. So I'm looking at pi r squared here. Well, r here is 9, so this is pi times 9 squared. The entire area is 81 pi. But I'm not looking at the entire area. I'm only looking at 105 degrees. So I modify this by taking 105 out of 360, timesing by that 81 pi. 105 degrees out of 360. So I can use a calculator here to give me a decimal value. 81 times 105 over 360. Notice I didn't use pi. So this is 23.625. 23 and 625 thousandths pi. I can make that a fraction if I want from the decimal. Or I can leave it as its mixed form here. 81 times 105. 8,505 over 360 with the pi at the end of it. Any of those will be acceptable. So 23 and 625 thousandths pi. This one is in square inches because it's an area. I hope this helps coming after school if you want some help on this test. These will be worth 5 points each in terms of point values since there's 20 questions. So I have on the front 50 points and I have on the back 50 points as well.